Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is a part 8 video on the chapter of time and work where I will solve the remaining problems of exercise 13B, which are the problems 13 to problem number 13 to problem number 17. In the previous video, that is part 7, I solved the problem number 1 to problem number 2, and I did a mistake. And came up with the wrong solution of the question number 10, which I will address first in this video. Before starting to solve the remaining problems, I will first talk about the incorrect solution of question 10 that I did in part 7, that is the previous video. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the remaining problems of exercise 13B, that is problem number 13 to 17 on the chapter of time and work from the textbook of author RS Aggarwal. Okay, so the question 10 was A can do a piece of work in 15 days. B is 50% more efficient than A. B can then finish the work in. The mistake I did was the wrong interpretation of the fact that B is 50% more efficient than A. I interpreted this to be that B will complete the work in half the time taken by A. This is wrong. So this interpretation that B will complete the work in half the time taken by A when it is given that B is 50% more efficient than A, this is wrong. So this is incorrect. This is wrong. Now, the mistake I did was not actually related to time and work, but I did the mistake in the concept of percentage. Now, B is 50% more efficient than A. First of all, if X is 50% more, X and Y are some quantity. If it is given that X is 50% more than Y, this does not imply that X is twice Y. X is twice Y. X will be double the Y. This is not true, because X is 50% more than Y. This will imply that X is 100 plus 50 divided by 100 multiplied by Y. This is 150 by 100 by Y. This is actually 3 by 2 Y. That is 1.5 times Y. So when I said that B is 50% more efficient than A, so definitely it will mean that B will take less time than A to complete a work. And I thought that B will complete the work in half the time taken by A. So that is the mistake. I thought that 50% more means twice, but it is not. So as you can see, if X is 50% more than Y, then X is actually 3 by 2 Y, which is, this is 1.5 times the Y, and not equals to twice Y. So this is the mistake I did. So anyway, I will approach the problem in a different way. Let me delete all the previous incorrect solution. Now, the fact that B is 50% more efficient than A, I will interpret this as B work done. I hope this time I will come up with the right solution. The correct solution is 10 days. Let me see. So work done by B in one day is 50% more than work done by A in one day. I hope this is the most appropriate interpretation of the fact that B is 50% more efficient than A. Now, what is efficiency? I think efficiency means the amount of work done in 1 hour or in unit time. Since not 1 hour in days, basically efficiency is the amount of work done in unit time. Since in this problem the time is in days, you can say that we can say that work done by B in one day is 50% more than work done by A in one day. Okay. Now, ultimately, we have to find in how many days B can complete the work. Okay. So, okay. So let assume. So let A. Let work done. So let work done by A in one day equal to X. So let work done by A in one day is equal to X. So this will imply work done by B in one day, since we know that the work done in one day by B will be 50% more than the work done by A in one day. So this will be 50% more than X. This is equal to 100 plus 50 divided by 100 into X, and this is 3x by 2. 3x by 2. Okay. Now it is okay. So B, so the work done by B in one day is 3x by 2. 3x by 2, which we can write it in the form of 1 by n as 1 by 2 by 3x. 2 by 3x. Now it is given that A can do a piece of work in 15 days. So we know that the fact that A can do a piece of work in 15 days, this means that the work done in one day by A is 1 by 15. So we can say that X is equal to 1 by 15. We have assumed that work done by A in one day is X, but it is already but it is given that A can do a piece of work in 15 days, which means that the amount of work done in one day by A is 1 by 15. So we have X equals to 1 by 15. Now, okay. Now from the fact that work done by B in one day is 1 by 2 by 3x, we can say time taken using the second general rule of time and work. We can say time taken by B to complete the work will be equal to 2 by 3x. Okay, so we know that the value of x is 1 by 15. Okay, so this will be 2 by 3 multiplied by 1 by 15. 1 by 15. This is equal to 2 multiplied by 15 divided by 3. This is equal to 10 days. This is equal to 10 days. So this was the correct solution. B is 50% more efficient than A. This means that the work done by B in one day is 50% more than work done by A in one day. And we have assumed that the work done by A in one day is X. So this will mean that the work done by B in one day is 50% more than X, which is 3x by 2, and we expressed 3x by 2 as 1 by 2 by 3x, so that we can find the time taken. So the time taken by B to complete the work will be 2 by 3x. Now we know that x will be 1 by 15 since it is given that A can do a piece of work in 15 days, which means that the amount of work done by A in 1 day is 1 by 15 from the first general rule of time and work. So we get x equals to 1 by 15, and substituting the value of x as 1 by 15 in 2 by 3x, we get the time taken by B to complete the work is 10 days. Okay. Now let's start solving the remaining problems. Question number 13. A can do a piece of work in 25 days, which B alone can do in 20 days. A started the work and was joined by B after 10 days. The work lasted for. So A did the work, A started the work and A worked for 10 days. So after 10 days, B joined. That is, for the first 10 days, A was working alone. And after 10 days, A and B was working and they completed the remaining work which was left once after 10 days when A was working alone. The work lasted for means what is the total number of days that was taken for A and B to complete the work. Okay. So now work done by A in 1 day is equal to 1 by 25. Also, work done by B in 1 day is equal to 1 by 20. Now, for the first 10 days, A was working alone. So, we need to find first what amount of work A completed in 10 days. So, work done by A in 10 days will be equal to, using basic unitary method, it will be 1 by 25, that is the work done in 1 day multiplied by 10. This is equal to 2 by 5. So 2 by 5 was done in 10 days by A. Now what is 2 by 5? 2 by 5 basically means 2 by 5 this fraction of the total work was completed in 10 days. So now what was the work left? The whole work we considered as the value of 1. So the work left will be 1 minus 2 by 5, which is 3 by 5 is the work left after A has worked for first 10 days. Now this work, that is the remaining work, that is which is 3 by 5, need to be completed by both A and B. Okay, so now work done by A plus B, that is when A and B are working together, work done by A plus B in 1 day is equal to 1 by 25 plus 1 by 20. This is equal to, the LCM will be the LCM will be 100. So 4 plus 5 by 100. This is 9 by 100. 9 by 100. 5, 4. Okay, 9 by 100. So work done by A plus B in 1 day is 9 by 100, which is equal to 1 by 100 by 9. Okay. Now we need to find that the A plus B, A and B has to finish the remaining work, which is 3 by 5. And we need to find how much time A plus B will take to finish the remaining work, which is 3 by 5. Okay. Now, we have found that in 1 day, work done by A plus B is 1 by 100 by 9. So this implies that A plus B will take 100 by 9 days to complete the whole work, to complete the work. Complete the work means complete the whole work. So A plus B working together will take 100 by 9 days to complete the work. So now we need to find how much time A plus B will take to complete a 3 by 5 work. Now the whole work means 1. Whole work means 1. So we can say that A plus B will take 100 by 9 multiplied by 3 by 5 this much days to complete, to do, to finish 3 by 5 part of the work. So the answer is 100 by 9 multiplied by 3 by 5. This is the answer, and this is equal to so 100 multiplied by 3 divided by 9 multiplied by 5. So 3 divides 3 and 20. So this is 20 by 3 days, and this is equal to 6 and 2 by 3 days. So the remaining work was 3 by 5, which will be completed by A and B both working together in 6 and 2 by 3 days. So what is the total time taken? What is the total number of days that was taken by both A and B to complete the work when A already worked for 10 days alone? So this implies the work lasted for 10 plus 6 and 2 by 2/3 days. This is equal to 16 and 2 by 3 days. So this is the answer. So the correct choice is C. Now while I am solving, I will quickly check whether my answer is correct or not. 13 is C, and which is correct. 16 and 2 by 3 days. Okay, let's do problem number 14. Two pipes can fill a tank in 20 minutes and 30 minutes respectively. So both are inlets. Okay. If both the pipes are opened together, then the tank will be filled in. So this is a straightforward question. We know that work done by let's say the first pipe is A. Let's say the two pipes B, A and B. So work done by pipe A in 1 minute. Since the unit of time in this problem is minute, we can say from the fact that the first pipe, that is A, fills a tank in 20 minutes, we can say work done by pipe A in 1 minute is equal to 1 by 20. Similarly, work done by pipe B in 1 minute will be equal to 1 by 30. So this implies work done by pipes A plus B, that is when both the pipes are open or both the pipes are working together, work done by pipes A plus B in 1 minute will be equal to 1 by 20 plus 1 by 30. Now what does it mean by work done by pipe A in 1 minute is equal to 1 by 20? This essentially means that in 1 minute pipe A will fill 1 by 20th part of the tank. So 1 by 20 plus 1 by 30 is 5 by 60. This is equal to 1 by 12. 1 by 12. Okay, so we can say that if you know that the work done by both the pipes A and B in 1 minute is 1 by 12. This will mean that time taken by A plus B to fill the empty tank will be equal to 12 minutes. From the second rule of pipes and cistern, we know from the rule of an outlet, not outlet, sorry, from the rule of an inlet, we know that if now the rule of an inlet says that if the work done by an inlet or maybe more than one inlet, if the work done if the work done per unit is 1 by n, if the work done by per unit is 1 by n, that is n is a positive number, which means that positive work done means that the tank is being filled. So if the work done in per unit is 1 by n, we say that the whole tank will be filled in units. So in this problem, we have work done by pipes A and B, A plus B, that is when both the pipes A and B are open or they are working together in 1 minute. Work done by pipes A plus B in 1 minute is 1 by 12. From this, we can say that the whole tank will be filled by A and B in 12 minutes. So 12 minutes should be the answer. The correct choice should be choice B. Let me quickly check the answer. Question number 14 is B. Okay. Question number 15. A tap can fill a tank in 8 hours and another tap can empty the full tank in 16 hours. Both the, let's say, the first tap P, this tap, that is the inlet BA, and the tap which is an outlet, and another tap, this tap can empty the full tank in 16 hours. So it is an outlet. So let's say this tap B. Okay. If both the taps are open, the time taken to fill the tank is. Okay. So we have work done. So definitely, if the tank is to be filled eventually, then definitely the work done by the inlet, that is the tap A, in 1 hour has to be more than the work done by the tap B, which is an outlet. So work done by tap A in 1 hour is equal to 1 by 8, or you can interpret this information as 1/8 of the tank is being filled by tap A in 1 hour. Okay. Similarly, work done by tap B in 1 hour will be negative. Always remember that the work done by an outlet is negative. That is, when the tank is being emptied, the work done is negative. This is the convention to use while solving problems on pipes and tanks. Okay, so work done by tap B in 1 hour will be negative of 1 by 16, since it is given that the tap B, which is an outlet, empties the full tank in 16 hours. So it will empty 1 by 16th part of the tank in 1 hour. So the work done in 1 hour will be negative of 1 by 16. Now we need to find what is the work done by both A and B, that is when they are both open or they are both working together. So work done by A plus B in 1 hour will be equal to 1 by 8 minus 1 by 16. This is equal to 1 by 16. So we are getting a positive work done. This means that eventually, if the work done per hour in a system of pipes and tank is positive, this means that per hour the tank is being filled with water. So eventually, if the tank is empty, it will be completely filled with water. So from so we get that per hour the work done is 1 by 16. So we can say now using the second rule of pipes and cistern, we can say that whole tank will be filled in 16 hours. Work done by A plus B in 1 hour is 1 by 16, and 1 by 16 is a positive work, it's positive. That means that water is being filled per hour, which also means that 1 by 16th part of the tank is filled by A plus B in 1 hour. From this fact, we can say that the whole tank will be filled by A plus B in 16 hours. So 16 hours is the answer. Hence, the correct choice is C. Let me check the answer. Question number 15 is C. Okay. Let's do problem number 16. A pump can fill a tank in 2 hours. A pump can fill a tank in 2 hours. Due to a leak in the tank, it takes 2 and 1 by 3 hours to fill the tank. So there is a leak in the tank. There is a leak in the tank, and that is why definitely water will leak out from that leak, which will slow down the filling of the tank, and that is why it is taking more time. It is taking 2 and 1 by 3 hours to fill the tank because there is a leak in the tank. Without the leak, the pump can fill the tank in 2 hours. But since there is a leak in the tank, the pump is filling the tank in 2 and 1 by 3 hours. So we can consider the leak as an outlet and the pump as an inlet. Okay. Now the leak can empty the full tank in. Okay. So it is asking how much time it will take the leak by the leak alone to empty a full tank. So to find this, we need to find how much work done, what is the work done by the leak in 1 hour. Okay. Now let the pump be, we denote the pump as A, as an inlet A, and the leak be the outlet B. So this is an inlet and B is an outlet. Since it's a leak, B is an outlet. So now we have is that work done by A in 1 hour will be equal to 1 by 2. Since it is given that the pump can fill a tank in 2 hours. So we can say that work done by A in 1 hour is 1 by 2. And let's assume that we have to eventually find the leak, how much time the leak will take to empty the full tank. So let's assume that work done, let's assume let the leak, that is the outlet B or tab B, let the leak empties the filled tank in X hours. The question is how much time the leak will take to empty the full tank, and we are assuming that the leak, which we have named as an B, we are assuming that the leak will empty the full tank in X hours. So we can say that work done by B in 1 hour will be negative of 1 by X. Since we have assumed that the leak will take X hours to completely empty the filled tank, this means that since it's a leak, it will do negative work. So we can say that work done by B in 1 hour is minus of 1 by x. Now this implies the work done by A plus B, work done by A plus B, that is the pump and the leak in the tank. Work done by A plus B in 1 hour will be equal to half minus 1 by x. This is equal to x minus 2 divided by 2x. Okay, this can be written as 1 by 2x in the form of 1 by n. We can express x minus 2 divided by 2x as 1 by 2x by x minus 2. Now, so we know that work done by A plus B in 1 hour is 1 by 2x by x minus 2. Now, okay, so we can say that time taken to fill the tank, to fill the empty tank by A plus B, that is the pump as well as the leak in the tank, will be equal to 2x by x minus 2. This is from the second rule of this is from the rule of the first rule of this is from the rule of the inlet. That is, if in 1 hour the work done is 1 by n, then we say that the whole tank, and if n is positive, we say that the whole tank will be filled in n hours. So applying that concept in this problem, we have work done by A plus B in 1 hour is 1 by 2x by x minus 2, which must be positive. So we can say that the whole tank will be filled by A plus B in 2x by x minus 2 hours. Now the work done A plus B means A is the pump and B is the leak in the tank. Now it is already given in the problem that due to a leak in the tank, it takes 2 and 1 by 3 hours to fill the tank. That is, when the pump and the leak both are working, then it is taking 2 and 1 by 1/3 hours to fill the tank. So now we can say that 2x by x minus 2 must be equal to 2 and 1 by 3. And 2 and 1 by 3 is 7 by 3. So we get a linear equation in x. We can easily solve for x. So we can say, doing cross multiplication, we have 6x is equal to 7 into x minus 2. This implies 6x is equal to 7x minus 14. So this implies x is equal to 14. X is equal to 14. And what was x? As per our assumption, the x was the time taken by the leak to empty the fill tank. So the answer is 14 hours. The leak alone will empty fill tank in 14 hours. So the correct choice should be D, that is 14 hours. Let me check the answer. 16 is D. Okay. So 14 hours. Okay. Let's do the last problem, that is problem number 17. Two pipes can fill a tank in 10 hours and 12 hours respectively. So both the pipes are inlets. While a third pipe can empty a full tank in 20 hours. That is, the third pipe is an outlet. So let's say these two pipes, inlets B, A and B, and let the third pipe, this pipe, that is the outlet P pipe or tap C. So we are naming the two inlet pipes as pipe A and B, so the pipe A can fill pipe A alone can fill an empty tank in 10 hours, and pipe B alone can fill an empty tank in 12 hours. Whereas the pipe C can empty a filled tank in 20 hours. So we have work done by A in 1 hour, since A is an inlet, will be equal to positive 1 by 10. Similarly, work done by B in 1 hour will be, since B is also an inlet, it will be positive 1 by 12. Similarly, work done by C, now C is an outlet, so the work done will be negative. It will be negative of 1 by 20. Now it is, the question is, if all the pipes are opened, in how much time will the empty tank be full? Okay. So now we need to find what is the work done by A plus B plus C. That is, A plus B plus C means all the pipes A and B and C are working together, or they are all open. So work done by A plus B plus C in 1 hour is equal to 1 by 10 plus 1 by 12 minus 1 by 20. So the LCM will be 60. LCM will be 60. So we have 6 plus 5 minus 3. This is equal to 11 minus 3 is 8. 8 by 60, which is equal to 2 by 15. So the work done by A plus B plus C in 1 hour, that is when the work done by all the pipes A, B and C in 1 hour is 2 by 15, and it is the work done 2 by 15 is a positive number, which means that the tank is being filled up per hour. So we can say now that the tank will be filled completely, or better we say the empty tank will be filled completely by A plus B plus C, that is when all the pipes are working together in 15 by 2 hours. Why? Because we know that the work done by A plus B plus C in 1 hour is 2 by 15. Now if we express 2 by 15 as 1 by n, this will be 1 by 15 by 2. So if the work done in 1 hour is 1 by n, we know for a pipe and tank, if the work done in 1 hour is 1 by n, where n is positive, then we say that the whole tank will be filled in n hours. So in this case, we got that the work done by A plus B plus C in 1 hour is 2 by 15, which is equal to 1 by 15 by 2. Then we can say that the empty tank will be completely filled by A plus B plus C in 15 by 2 hours. So 15 by 2 hours is equal to 7.5 hours. 7.5 hours. Now, okay, so 7.5 hours is the answer, but the choices are given as hours and minutes. So 7.5 hours definitely means 7 hours and 30 minutes. So 7 hours 30 minutes should be the answer. That is, choice B is the correct choice. Let me quickly check the answer. Question number 17 is B, 7 hours 30 minutes. So this brings to an end in solving the remaining problems of exercise 13B on the chapter of time and work from the textbook of author RS Aggarwal. So this brings to an end in discussing and solving the concept of chapter time and work, and solving the exercise problems of the textbook of author RS Aggarwal. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Now, I will not make any further assignment on this chapter, but rather I will prepare and solve a little harder problems in the other playlist, that is Maths 8 Hot. In the playlist Maths 8 Hot, I usually solve relatively harder problems from all the chapters as and when they are completed in this playlist, that is CBSE Maths 8 RS Aggarwal. So please keep an eye on the playlist of Maths 8 Hot, where I will solve some harder problems on this chapter of time and work. So I will end the video here. Thanks for watching, and until the next video, take care and bye.